What if I told you that 124 light-years away, hidden in the shadows of a cold red star, a distant ocean world may be sending us the first signs of alien life? The James Webb Space Telescope has detected something impossible to ignore, a gas we've only ever seen on Earth and only created by living things. In this video, we'll uncover what this mysterious exoplanet is, what scientists have found in its skies, and why some believe it could solve or deepen the Fermi Paradox. This may not just be a discovery, it could be the start of a new era in human history. Somewhere in the vast silence of space, a planet orbits a small, faint star. From Earth, it's just a data point, a flicker in the sky, one of thousands cataloged by astronomers. But then, something changed. Scientists pointed the most powerful space telescope in human history, the James Webb, toward this distant world. And what it saw shook the foundations of astrobiology. K2-18b, that's the planet's name, doesn't look like much at first glance. It's bigger than Earth, smaller than Neptune, but it sits in its star's habitable zone, the region where temperatures might allow liquid water to exist. And more than that, its atmosphere is whispering secrets, secrets that sound eerily familiar. Water vapor, methane, carbon dioxide, and most shocking of all, possibly dimethyl sulfide, a gas that, on Earth, only comes from life. It isn't just about another exoplanet. It's about what we found there, why it matters, and what it could mean for the biggest question humanity has ever asked: are we truly alone? K2-18b, a cold, clinical name, the kind of name you'd expect for a rock cataloged in some distant star system. But behind those letters and numbers lies one of the most intriguing planets ever discovered. It was first detected in 2015 by NASA's Kepler Space Telescope, a mission built to find planets by watching stars dim ever so slightly as something crossed in front of them. That something was K2-18b, a planet that would soon spark intense scientific curiosity. It's classified as a sub-Neptune, bigger than Earth, smaller than Neptune. Too massive to be rocky, yet not big enough to be a gas giant. A strange in-between world. But it wasn't its size that caught scientists' attention. It was its location. K2-18b orbits within the habitable zone of its star, the sweet spot where temperatures might allow liquid water to exist. And water, as we know, is life's favorite playground. Its host star is a red dwarf, cooler and smaller than our Sun, but stable and long-lived. That means any potential life on K2-18b could have had billions of years to evolve. The planet itself is about 2.6 times Earth's size, with roughly 8.6 times its mass. It likely has a thick atmosphere, and possibly vast oceans hidden beneath clouds and hydrogen-rich air, a world of eternal twilight and alien chemistry. They found something they never expected. And what came next was even more astonishing. Back in 2019, something strange showed up in the data. Scientists using the Hubble Space Telescope detected water vapor in the atmosphere of K2-18b. That alone was a huge deal. Finding water in an alien atmosphere, even just vapor, instantly places that planet on the short list of places that could host life. But at the time, it was still just that, vapor. Promising, yes, but not exactly groundbreaking. That would change 4 years later. In 2023, the James Webb Space Telescope, the most advanced observatory ever put into space, was finally pointed towards K2-18b. Its instruments, capable of detecting the tiniest molecular fingerprints in alien atmospheres, scanned the light passing through the planet's atmosphere as it transited its star. What it found stunned the scientific world. JWST confirmed the presence of water vapor But it didn't stop there. It also detected methane and carbon dioxide, two gases that, on Earth, are tightly associated with biology. Now, methane can be produced by volcanoes, and carbon dioxide is common in planetary atmospheres. But when these three gases show up together, water vapor, methane, and carbon dioxide, in the right ratios, it starts to resemble a chemical recipe for life. The findings were so compelling that scientists began to wonder, could K2-18b be more than just a watery world? Could it be what's known as a Hycean planet, a theoretical type of planet with a vast global ocean, a thick hydrogen-rich atmosphere, and conditions that could support microbial life beneath the surface? At this point, K2-18b had gone from being a mildly interesting exoplanet to one of the most promising candidates in the search for extraterrestrial life. But just when scientists thought they had uncovered something remarkable, the data revealed something even more bizarre. A fourth gas, one that shouldn't be there. A chemical that, as far as we know, only living organisms can produce on Earth. And that's when everything changed. Among all the gases James Webb detected in K2-18b's atmosphere, one stood out like a glowing beacon in the dark. A molecule called dimethyl sulfide, or DMS. It's not just rare, it's weird. On Earth, DMS has one source: life, specifically tiny ocean-dwelling organisms like phytoplankton, the microscopic plants of the sea. When these creatures thrive, they release DMS into the air as a byproduct of their life processes. And that's what makes this so astonishing. There are no known natural, geological, or chemical processes that produce DMS in large quantities without biological activity. So when scientists saw a spectral signature that looked a lot like DMS in the atmosphere of K2-18b, their jaws dropped. Was this it? Was this the moment humanity finally detected the chemical signature of life on another world? Now, let's be cautious, and the researchers certainly are. The detection is still considered tentative. It sits at what's called the 3 sigma level, statistically significant, but not enough to declare a discovery. There's still about a 0.3% chance it could be noise or contamination. But even at 3 sigma, the implications are staggering. And it wasn't just a fluke. JWST used a completely different instrument to confirm the presence of the molecule. That's like taking 2 separate photos of the same ghost and having it show up in both. Even more strange? The amount of this gas. On K2-18b, the estimated concentrations are up to 20 times higher than what we see on Earth. If this is real, then whatever is producing it isn't doing so casually. It would require a massive planet-scale process, the kind of process we only know life is capable of. But as every good scientist knows, extraordinary claims require extraordinary evidence, and that's where the tension lies. Because while this might be the first whisper of alien life, it could also be something else, something more mundane, or something we've never seen before. But before we start celebrating, we need to ask the harder question. What if it's not life at all? It's tempting to jump to conclusions, to look at a signal like dimethyl sulfide and immediately declare, we've found life. But science doesn't work that way. It's cautious, deliberately, painfully cautious, especially when the stakes are this high. And there are good reasons to be skeptical. For starters, the detection of DMS, while exciting, is still at the 3 sigma level. That means there's roughly a 1 in 300 chance that what we're seeing is nothing more than random noise, an illusion created by the complexity of the data. Scientists don't pop champagne until a signal hits 5 sigma, the gold standard of statistical certainty. That's the difference between maybe and almost definitely. Then there's the problem of interpretation. What if there's a completely unknown chemical reaction happening on K2-18b that produces DMS without any involvement of life. After all, we've only studied one example of a life-bearing planet, our own. It's entirely possible that alien worlds play by a different set of chemical rules, rules we haven't even imagined yet. Some researchers have also raised eyebrows at the sheer quantity of DMS-like molecules being detected. The levels appear to be 20 times higher than on Earth, which is both exciting and suspicious. Could life really produce that much gas? Or is there something else happening in the atmosphere, something exotic, something we've never seen before? And yet, the possibility remains, because for all the doubt, all the caution, all the alternative explanations, nothing has been ruled out. And what's especially compelling is that every single piece of data collected so far, from water vapor to methane to the potential DMS, lines up with predictions made by theoretical models of what a life-bearing Hycean world might look like. That eerie alignment between theory and observation has some scientists quietly wondering, what if this really is it? But let's pull back for a second. Even if this detection turns out to be real, even if it is life, it's not the kind of life most people imagine. It's not intelligent, it's not building cities or launching rockets. It's likely tiny, simple, and completely hidden beneath a global ocean, which raises an even bigger question. What does this mean for life elsewhere in the universe? And could it help explain why we haven't heard from anyone yet? If what we're seeing on K2-18b is real, if that dimethyl sulfide signal is truly biological, then we may have just crossed a threshold, because this wouldn't just be the discovery of life on another planet. It would be the discovery that life can emerge in places radically different from Earth. It would mean that biology isn't some rare, delicate fluke confined to a pale blue dot orbiting a yellow star. It's something that the universe does, given the right ingredients. And here's the part that sends chills down the spine. K2-18b orbits a red dwarf star, the most common type of star in the Milky Way. These stars are small, cool, and dim, but they last for trillions of years. In fact, about 73% of all stars in our galaxy are red dwarfs, and most of them are believed to have at least one planet in the habitable zone. If even one of those planets shows signs of life, like K2-18b possibly does, then it strongly suggests that life might be common across the galaxy. Not intelligent life, not yet, but microbial life, the kind that lives in oceans, hides in atmospheres, and quietly changes the chemistry of entire planets. That type of life may not be rare at all. It could be everywhere, waiting patiently for us to notice. And perhaps that's the answer we've been missing all along. Maybe the reason the universe feels so quiet is because most life doesn't shout. It doesn't build radio towers. It doesn't send signals. It just exists, deep in alien oceans, under thick clouds, in places we've only begun to explore. But if this is true, if microbial life is spread across the stars, then we're faced with a sobering possibility. What if most of it is stuck, trapped on worlds where intelligence can evolve, but never escape? What if life isn't rare, but trapped? Let's imagine, just for a moment, that microbial life is thriving on K2-18b. It swims in vast alien oceans, feeds on energy from hydrothermal vents, maybe even forms complex ecosystems beneath an endless blanket of clouds. But here's the heartbreaking part. It might never know the stars exist. K2-18b is a Hycean world, possibly covered entirely in water with no land in sight. And with gravity nearly 9 times stronger than Earth's, anything living there would face a colossal challenge just moving upward, let alone launching into space. There would be no fire, no metallurgy, no machines, no way to build a rocket. Even if a species developed tools or language or dreams, they'd be locked beneath an ocean ceiling forever. And that's not just science fiction, it's a very real possibility. In fact, if most habitable planets out there are ocean worlds like K2-18b, then intelligent civilizations could be incredibly rare, not because they don't exist, but because they can't escape. They live and die in the depths, invisible and unreachable. This could be a clue to solving the Fermi Paradox, the eerie silence we hear when we ask, "Where is everybody?" Maybe the galaxy is full of life, but none of it can speak, or travel, or build. They're watching their suns from below, dreaming of something more, forever wondering what lies above the waves, unaware that the universe is just beyond reach. And perhaps, just perhaps, it's our destiny to be the ones who reach out. But before we imagine ourselves as interstellar rescuers, there's one final astonishing possibility we have to consider. What if what we found on K2-18b isn't biological at all? What if it's something far more advanced? There's one last twist in this cosmic mystery, one that flips everything we've considered on its head. What if the strange gases detected on K2-18b aren't from life as we know it? What if they're not natural at all? Because here's where things get strange. If K2-18b turns out not to be an ocean world, if it's more like a mini gas giant with no surface and no water, then many of the biological explanations fall apart. And in that case, the presence of dimethyl sulfide, or anything like it, becomes incredibly difficult to explain through geology or chemistry. If it's not nature and not biology, that only leaves one possibility: technology. It sounds like science fiction, but the idea of technosignatures, chemical traces left behind by advanced civilizations, is taken very seriously by parts of the scientific community. Could we be mistaking an alien industry, or energy process, or even the remnants of a long-dead civilization for biology? Maybe the signal isn't life. Maybe it's the echo of a civilization, long gone or still hiding in the clouds of a distant world. And if that's true, then this isn't just a scientific discovery. It's first contact. Of course, this is all speculation. We're still in the earliest stages of understanding what's really going on around K2-18b. More observations are coming. More instruments are being prepared. But one thing is clear: whether this turns out to be life or something else entirely, we've crossed into new territory. The area of scanning exoplanets for signs of biology, chemistry, or intelligence has truly begun. And even if the signal fades away or turns out to be nothing more than noise, it means we've sharpened our tools. We're ready for the next whisper from the cosmos, because this is just the beginning. Whether or not K2-18b turns out to host life, this moment is already historic. Because for the first time, we're no longer just looking up at the stars and wondering. We're searching. We're analyzing alien atmospheres, decoding light across unimaginable distances, and asking questions that just a generation ago would have sounded impossible. And even if the dimethyl sulfide turns out to be a false alarm, it means we're learning. We're refining the instruments, training the algorithms, and preparing for the next signal, the next planet. But if it's real, if this is truly life, even simple microbial life, then it means we are not a cosmic accident. It means the universe doesn't just allow life, it creates it. And that changes everything. So don't look away. This story is far from over. Because somewhere out there in the quiet dark, something is waiting to be discovered. If this story left you wondering what else might be out there, then you're not alone, because the search has only just begun. Curious about our next destination? Stick around for the next video.